This video is all about point-slope form of a line. Stick around as I go through point-slope form and go through several examples that you may be asked regarding point-slope form of a line. So first of all, point-slope form looks like this. Y minus y1 equals m times x minus x1. And the information you need to write the equation in this form is right in the name, point-slope form. So to use this form, you need a point, which we will call x1, y1, and you need a slope, which we will identify as m. Once you have those two pieces of information, you can plug it into point-slope form. Let's take a look at our first example. Here we are given a point and a slope, and we are asked to write the equation of the line in point-slope form. So once again, remember point-slope form is y minus y1 equals m times x minus x1. And the point that we're given, that's going to be the x1, y1, and the slope we identify as m. Simply plugging these values into point-slope form, we would have y minus, and here we would need to subtract a -3. Well, if you subtract a negative, we can change that to +3 equals the slope, -5, times x minus x1, which in our case is 12. And there is the equation given the point and slope in point-slope form. Let's take a look at another example that is commonly asked about point-slope form. Here we are asked to graph the line, and the line is given in point-slope form. A lot of times I see students really want to put this into slope-intercept form. So they distribute the 2/3 and they subtract the 5/. Well, you know what? If you did that on this example, you would have y equals 2/3 x minus 29/3. That's a crazy equation. And plotting a y-intercept of -29/3 is not so fun, and I tell them don't go through all that extra work, just graph it from point-slope form. So we should be able to identify the point from this equation simply by working backwards, taking the information from point-slope form and then also the slope. Okay, because point-slope form is y minus y1 equals m times x minus x1, I can simply look right here to get the x-coordinate of the point. X minus x1, x minus 7, so 7 is my value of the x-coordinate of my point. Let's head to the y-coordinate of the point. Here, I have a +5. Remember the last example when I subtracted a negative? That's why it switched to positive. So here if I have a +5, the y1 must be -5 so that when we subtract that -5, it becomes positive in our point-slope form. Finally, we have our slope. And our slope would be right here in front of the parentheses x minus 7. So my slope is 2/3. Now that we've identified that information or pulled that information from our point-slope form, we're ready to graph. First, graph the point 7, -5. The x-coordinate is 7, the y-coordinate is -5. So that would be the point right here. Finally, I need to graph a slope of 2/3. So that means I would rise 2 and then go to the right 3 since the slope is a positive 2/3. Let's go back down the other direction and graph this line. And as you see, that saved you a whole lot of work rather than distributing the 2/3, writing it in slope-intercept form to graph it. Just graph it directly from point-slope form. If you're finding this video useful so far, make sure to click subscribe so that you're notified as new math videos are posted each week. Let's take a look at another common example about point-slope form. This time you may be already given the graph of the line and we actually need to write the equation. Well, let's just work backwards from what we just did. So let's identify a point on this line, and let's also identify the slope. Once we have a point and a slope, just like the name of the form is called, point-slope form, we can go ahead and write it in that form. So first we need a point. Well, we've got lots of points to choose from. If you think about it, I could choose this point right here, or I could choose this point right here, or this point right here. It doesn't matter which point you choose, they would all be correct if you plug it into point-slope form. I'll go ahead and use this point right here. The coordinates of that point is -5, 5. Now I need the slope. Well, it helped that I put a couple points on that graph because now I can identify the slope. Going from this point to this point, it looks like I go down 3. And I go to the right 2. So it looks like my slope is -3/2. So my point is -5, +5, and my slope is -3/2. I have all the information, x1, y1, and my slope that I need to write it in point-slope form. All right, here I go. Y minus y1 equals m times x minus x1. Once again, don't forget double negative, change that to positive. And here is the equation of this line in point-slope form. Just a reminder, I could have chosen this point, or this point, or this point with the same slope of -3/2, and as long as I chose a point on the line and the slope of -3/2, that would be correct. Let's take a look at one last example, this time where you are given 2 points and asked to write the equation in point-slope form. So I always ask myself, I look at the name of the form. Do I have a point? I sure do. In fact, I have 2 points, so I'm good to go on that one. Now the slope. I don't know the slope of this example, so I would want to start this problem by finding the slope. Because I'm given 2 points, I would want to use the slope formula. And the slope formula is y2 minus y1 divided by x2 minus x1. I'm going to label this point as x1, y1, and this point as x2, y2. Let's go ahead and plug that into the formula for slope. y2 minus y1 would be 4 minus a -3, so that'll change to plus. x2 minus x1 would be -6 minus 8. Looks like I get 7 over -14, which reduces to -1/2. Now I have everything I need. Now I have a point, in fact I have 2, and I now have the slope of -1/2. I'm ready to plug it into my point-slope form. Let's go ahead and use the first point to write my equation in point-slope form. Y minus y1 minus a -3, changes to +3, equals my slope, -1/2, times x minus x1, which is 8. Once again, I got that from using the formula for point-slope form. And here it is, once again, for your reference. And that would be the answer. But you may be wondering, oh, I used the point -6/4. Am I wrong? And the answer is absolutely not. It turns out there's 2 possible answers for this one. Your other answer could be y minus y2 equals the slope that we found times x minus -6, which will change to plus. This one is also correct. Now, why are they both correct? It turns out if I were to change both of these 2 equations into slope-intercept form, both of them would give me y equals -1/2 x plus 1. So in fact, they are both correct because they both, after simplified, distributing in the slope and getting y all alone, I would get y equals -1/2 x plus 1 for both, thus showing that you have the same exact line. I hope you found this video useful about point-slope form and common examples that are asked of this form. If you did find this video very valuable, make sure to like it and click subscribe so that you're notified as new videos are posted weekly. Thank you so much for watching.